gena nyepamne ne kudlukula oke nongoto ni beti sola ibuloke dato ni betoto
Mingi Congo
Lamin
na
Lamin te jibe norin te nyame Lamin
kama na wulo
kono nyinte mo Lamin
pabilenki
muna ngata afamole
haina
ngata ngoto le Fabrama
Mingi babanya
ngoto le Fabrama
namu jumala kan kuma ni ten
Fabrama
jumala mu
ndele bare muso
lunda mana
kata
jamani mbere
lindo ko
jamani
bari ngoto man kontande
bari jamani fana na ramu man kontan
ngoto minaka ngala filitala Lamin jibe
Lamin ila fane bi ya so tol sayni no ko mo lokko momo
ngoto
nam
itirinte yalo ne Lamin hakkilo diata bake ngoto anu santen ministry ko di ngole si suwo ko amanke ko do holi de
si bitun
bagona de
ala ni nyaba ko kede namo balo
ala ni na ko na karta bulo be dam ala ni je
ngoto
nam
ngoto mon kontan fere
jamani mu ne keda
ife ke Lamin ki wulo ko no nyintay mon ko do fete malo Lamin nyande sila la be la moy kala
jamani karam ne ko fasita wulo ko nako
baba
karam wol ma ko ni ko karam wol soro ndama ke comme holiday lem ngoto dini wonyanta sila la ala karangola mo yamen kaben fue man kontan andamande
alla nyin kombo courant adanda la kombo len do la jankara mol soro ndar do kamen courant ma rado la kombo e don dol fanena kara mol soro je kara mol soro Lamin adara lo nyino la aman tara fena so ala mu nekela
ama Lamin ite foyde malon ko lesinol be ke kar radio to
nga fine
e ko nyani mo ya mu na fonye
bi kabin mina kan ntambita nteri manyin Fatu ndambide la sukala ala diningol bebe siri be la moyka
faru dan so am fana tambira jele ni subala la ngaje diningol be jet talanta nen kili waro e be seri jelet
sa Lamin fanante ku kili wo ke no la ba Lamin bitaka wulo ko no nyinta mo Lamin
aman dara fenela
ite dine ko di man si yakaru la suno la moy radio to e balon na
mu ne ka ke afonde ma nyaara ni alon
kelentel jikot
afonde ma mu be ke
ite balon tel be jikritel ni man karam be ku kele yaje nata karana mbasa malaya ay tarije
par ñarande kombo courant ho findira kombo ide na rajede ni sonka bay ko Lamin ma ñata la wulo ko karam mo be so dafa ne membe
ko to wole nati bayo ngalle ni Lamin kuntala kombo courant e ka fa me kombo courant asototal wala kinay ko e sisu kono bari ni ko e sisu kono be di ke la radio lin telel to hani tele masoto to nyaay man tele soto la bongo bar radio be bulen koto batiri sanga ay si ay ala mo
sa do kala
nyaadi ko ta ho bulaji
ado kala nyaadi
kamun ke nyaadi
radio abe wala mo la be mona falaje
ibe la karandirol kala jele
ti talle be radio ko men ka karandirol
il est subjecteur baby jele baby jele
wala nan ka coco moy fa dan so wala ngombe tambi ka nga dinni wolde be ikadum bungo ko kala
ma asoto tal de
Lamin mala be kara wala de
bari laftalal ideal on ko inde every year second wala fourth
muna ni ko di ha ko ndego folle sinila mba ndele sinilo ne ba
mba say mba foke en koto wole fango yen wulindi yalo famo keta bat ñu fana bulata ko ko me yen nati jambi Lamin nyanta karana ndel be jiko be nyineka ya bulay kara wulo kono ta kilar ya bambalo yo be bulaje koto dinni ngoy si ayala le sino la moy radio
wora ka munda kara mo man soro Lamin nyanta kara si so na regular
la sila le ayala le sino
dal ko korno ko smalo
kilar ya
be ngala ko momo sa mbi do ni ko no kera
mengi bro
ndelo ko la da ba rosa no radio ba no bari woro radio ni abe jele ba do ngamra do man dembe buljan dala nyara nyar wofra bu ko fendi mo la Lamin tayra ba rosa
bara te ku folo ajibe nori nya Lamin tamete ku
teku
bari ko do famo ke
ja image nañu ñambol si zol le keje kisgi man si zol no le kafum ka ñoma bari ñambu kino ni mañana ka finde ni nambe ko zol la ga
ngalle limbeta de be ñambo do dilanna
ñara nim ko ridin fennat ñara nata
bari famo ke da
ngata bungono tammi bungono ñara ngando ko fele ko ke baru nganda ni pelo la ndija
iyo awa
la bungono bismillah bisu diara
pendulala yefungo tanka sina dulu tanka koro korota koro
Hello viewers and listeners. Welcome yet to another mathematics lesson for the upper basic level. And all through our previous lessons, we have gone through solving equations. Now we're moving on to word problems on equations. Okay? Now, algebra is often used to solve problems given in words and sentences. To solve such problems, follow the following steps. Step 1, read the information given carefully. You know, they said reading the information given to you carefully and understanding it is almost halfway towards answering a question. So always read the question very carefully so that you can know what information is given and also what are you required to find. It's very important. Then step 2, choose a letter to represent the unknown quantity or value. All right? Whatever you are required to find, use a letter to represent that. That is your step number 2. Then step number 3, use the information to find two equal expressions. Then write these expressions as an equation. So use the information given to you to find two equal expressions and then use those two expressions as an equation. And then step number 4, solve the equation you have and use the solution to answer the questions. So the equation you have developed from step 3, solve it to answer your question, all right? And then step number 5, finally, use the original information given to check your solution. It is always important to check whether your answer makes sense or not, okay? If we look at example 1 here, it says Fatu thinks of a number. She added 6 to it and the result is 17. Find Fatu's number. It's always important to read the question very carefully, all right? So here what we know is that Fatu thought of a number. Afterwards, she added 6 to that number, and then the result was now 17. So we want to find what was Fatu's number. Now, let's see what happens here. Of course, first we know that Fatu thought of a particular number, but do we know which number? We don't. So because we don't know which number Fatu thought of, we can use a letter to represent Fatu's number. All right? So our solution here, since we don't know Fatu's number, we can start by saying, let Fatu's number be a variable x. Of course, you can choose a different variable if you want to, but I'm choosing to use x in this case, all right? So we know now the number Fatu thought of is x. So we're starting from there. So Fatu thought of x. Now, after thinking of x, what did Fatu do? She added 6 to the number. That means plus 6. All right? And then after adding 6 to the number, what happened? The result was 17. That means this is equal to 17. So you can see what we have done here is that we have created two expressions from the question and then used them to form an equation. Because x plus 6 is an expression, and then the 17 as well is also an expression. And we have used those two expressions to form an equation. So therefore, our equation is x plus 6 is equal to 17. From here now, all you do is to solve. And of course, we have learned many times before how to solve an equation. We want to find the value for x here. the x is there with plus 6. So therefore, we need to undo the plus 6. And we know that the inverse of addition is subtraction. So therefore, we are going to subtract 6 from both sides. So if we subtract 6 from the left-hand side, also subtract 6 from the right-hand side. And then what happens? The 6 will cancel out the 6 on this side, on the left-hand side. So now you are left with what? X only on the left-hand side. That is now equal to 17 minus 6 should give us 11. All right? So it means Fatu's number was 11. But what do we do? Let's check if our answer makes sense. All right? If you go back to the question, what we are told was that Fatu thought of a number. And now we know the number is 11. Then she added 6 to it. And the result is 17. So now let's see if you put that 11 in place of x, whether the two sides of the equation would be equal. If they are equal, then our answer is correct. If they are not equal, then we have done something wrong along the way. So let's prove it. We need more space to write on. And we will have, what we had was x plus 6 is equal to 17. X now we know is 11. So 11 plus 6 is equal to 17. And 11 plus 6 surely gives us 17. And 17 is definitely equal to 17. So it means our answer was right. So Fatu's number therefore was 11. Right, then we move on to a second example. It says when 2 is subtracted from a number, the answer is 12. Find the number. All right? When 2 is subtracted from a number, the answer is 12. Again, what we know is 2 was subtracted from a particular number. But which number, we don't know. So because we don't know which number 2 was subtracted from, we're going to use a letter to represent that number. So we can again start by saying, let the number be, let's say, y. Okay? So we know the number is y. Now, we know 2 was subtracted from that number. So the 2 was subtracted from y. It means from the y, you subtract 2. That should be the meaning. You are subtracting 2 from the number. So that is y minus 2, because our number in this case, we have chosen y to represent it. Now, after subtracting 2 from y, the answer was now equal to 12. Again, what have we done? We have used our equation to form two expressions and then equate them to form an equation. Because the y minus 2 is an expression and the 12 is another expression, and we use those two expressions to form an equation. Those two, if you simplify, should end up being the same. Now, once we have got our equation, the rest is now easy, because solving equations is now very easy for us. We know we want to isolate the y, but the y is there with minus 2, that's a subtraction. So we need to undo that subtraction, and we know the inverse for subtraction is addition. So therefore we need to add 2 to both sides of the equation. So we're going to add 2 to the left hand side. You also add 2 to the right hand side. Then let's see what happens. The 2 will cancel out from the left hand side, and now you are only left with y on that side, being equal to, if you add 12 plus 2, that should give us 14. So it means our number again in this case is 14. But again, let's prove and see if our answer makes sense. Okay? What we are given was 2 is subtracted from a number. We chose y to represent the number. So that's why we said y minus 2. And then the answer was 12. So that's why we had y minus 2 is equal to 12. So now let's put our answer in place of y and see if the two sides of the equation would be equal. Okay, now let's prove that. We need space to write on that. Let's see. What we had was y minus 2 is equal to 12. Y we know now is 14. So 14 minus 2 is equal to 12. If we subtract 14, or 2 from 14 rather, you would get 12. And 12 is definitely equal to 12. So again, that proves that our answer here is also correct. So therefore, we can move along to a third example. It says, when the product of 3 and a certain number is increased by 1, the result is 22. Find the number. Again, let's look at this very carefully. It says, when the product of 3 and a certain number is increased by 1, the result is 22. Find the number. Now, before we even start to work, let's try to pick out some key terms here. And we can see that there are two terms that are particularly important here. One, the product. And then second is increase. Again, we have come across this in our previous lessons. Product, if we remember, means multiplication. All right? And increase also, if you recall, it simply means addition. But again, we know that when the product of 3 and a certain number, a number which we don't know, all right? So because we don't know which number that was, you can always start by assigning a letter to that number. So yet again, we could say, let the number be x. Okay? So we know our number is x. And we know the product of 3 and that number. That means if you multiply 3 by our number, which is x, is increased by 1. Increase, we know, is addition. So if you add 1 to that product, the answer which you get, as the result, is 22. Now that is what we have at the beginning. Of course, we need to simplify this a bit further. We know 3 times x will simply give us 3x. Bring down the plus 1 is equal to 22. Now that is the equation which we now have, and all we do from here now is just to solve for x from here. We want to isolate the x, but first we need to undo the addition. Remember, when solving equations, you reverse the order of operations, right? You work backwards through the order of operations. So we need to undo the addition before undoing the multiplication. And we know the inverse of addition is subtraction. So therefore, we will subtract 1 from both sides of the equation. So minus 1 from the left-hand side, also minus 1 from the right-hand side. And what happens? You now have 1 cancelling out 1 from the left-hand side. And what is now left on that left-hand side is simply 3x. Now that is equal to, on the right-hand side, you have 22 minus 1. And 22 minus 1 should give us 21. But is that our answer now? No, that cannot be the answer, because remember, we are trying to isolate the x, and still now the x is there with a number or a coefficient. But we know 3x is 3 times x, which is a multiplication, and to undo a multiplication, you divide. So therefore, we're going to divide both sides by 3. Over 3 over 3. So that 3 will cancel out 3 from the left-hand side. Then now you have x being equal to 3 into itself is 1s. 3 into 21 should give us 7 times. So our answer is 7. But like always prove your answer to be so. All right? There's no point in moving along when you are not sure whether your answer is right or wrong. So always take your time to prove the answer. Go back to your question. What were you told? That when the product of 3 and a certain number, we know that now that is 3 times x, is increased by 1, that is plus 1, the result is 22. That was what gave us 3x plus 1 equals to 22. So if we put 7 in place of x, then the two sides of our equation should be equal. Otherwise, there's a problem with our solution. So let's confirm that. Let's see. Let's find a space to write on. So what we have was 3x plus 1. Will that be equal to 22 if we substitute? X we know is 7. So that's going to give us 3 times 7 plus 1. Will that be equal to 22? Okay. If we simplify this, 3 times 7 will give us 21 plus 1. Will that be equal to 22? And obviously, 21 plus 1 is definitely 22, and 22 is solely equal to 22. So again, it proves that our solution was right. So x was 7. Okay. Now let's look at a fourth example. And I'm sure by now you can walk ahead of me and see by the time I get to my answer whether it is going to be the same answer that you also arrive at. It says when a certain number is subtracted from 10 and the result is multiplied by 2, the final result is 4. Find the number. Now that's a lot of words there. Again, let's look at it very carefully. It says when a certain number is subtracted from 10 and the result is multiplied by 2, the final answer or the final result is 4. Okay? Now let's find this number. First, we don't know the particular number we are talking about here, right? And we know whenever you don't know the value of a number, you can always use a letter to represent it. Okay? So again, we can start by saying our solution would be, let the number be x. Let the number be x, okay? Now we know the number was subtracted from 10 All right? Which means from 10 you subtract the x. That gives you 10 minus x. And then what happened? The result of doing that was multiplied by 2. That means what you now have just done right now, you multiply all that by 2. And here the use of the brackets is very important, because if you don't use the brackets, you may run into some trouble. So employ your brackets here, all right? So when you subtract the number from 10 and multiply all that by 2, your final result was now 4. So this is equal to 4. Right. All we do from here now is just to solve this equation. Okay? And we know, because what we have is 2 into 10 minus x being equal to 4, we must apply our distributive property here, which means we need to expand the brackets, which by now we know how to do. You simply multiply every term inside the bracket by the term outside the brackets. So we will have 2 times 10, which gives you 20, minus 2 times x should give us 2x and 4. Now that is now our brackets gone. So what we do from now is just to solve. All right? We want to isolate the x, but first we need to undo this 20. This 20 is positive, all right? And to undo an addition, you subtract. So therefore, we're going to subtract 20 from both sides of the equation. So we'll say minus 20 from the left-hand side, also minus 20 from the right-hand side. Then let's see what happens. The 20s from the left-hand side will cancel each other out. And what we are left with there now is the negative 2x. So you bring down the negative 2x. So you get minus 2x is equal to 4 minus 20. If we subtract 20 from 4, that should give us negative 16. Okay? So now we have negative 2x being equals to negative 16. Negative 2x actually reads as negative 2 times x. So that's a multiplication. And to undo that multiplication, we simply have to divide. So divide both sides by the negative 2. Both the left and the right hand side. Divide them by negative 2. And then the negative 2 will cancel out the negative 2 from the left hand side. And what you are left with there now is, you are now left with only x from the left hand side being equal to. Now on the right hand side, you can see that both the 16 and the 2 are negative. So therefore those negatives will cancel each other out, because we know a negative divided by a negative will be positive. So they simply cancel each other out and they turn into positive. Then now 2 into itself will be once, and 2 will go into 16 exactly 8 times. So our number in this case was 8. But again, let's prove it. Going back to your question, we were told that when this number was subtracted from 10, and then the result was multiplied by 2, the final answer or the final result is 4. That was the question, and that was what we used to arrive at 2 into 10 minus x being equal to 4. All right? So now let's use that to prove our answer. We had 2 into 10 minus x should be equal to 4. All right? We know now our x is 8. So we're going to write 8 in place of x. And that will now give us 2 into 10 minus 8, because x is now 8, will that be equal to 4? All right? If you further simplify this, what you have is 2 into 10 minus 8 should give us 2, and that is equals to 4. If you multiply 2 times 2, you definitely get 4, and 4 is equal to 4. So again, that tells that our solution was right, because the two sides of the equation are still equal. Right. Then we can move along to one last example before I will give you an assignment to work with. Example number 5. It says, if 1/3 of a number is added to 1/5 of the same number, the result is 8. Find the number. All right? 1/3 of a particular number is added to 1/5 of the same number, then the answer becomes 8. Now, what is that number? Let's follow the same procedure again as before. We don't know what the number is, so therefore, we are going to use a letter to represent that number. Let's say x again. If you don't want to use x, you can use a different alphabet or letter of the alphabet. So let the number be x. So our number here is x. Now 1/3, all right? 1/3 would be, we know from the term there, third is 3. And 1/3 simply means 1 out of 3. That is 1/3 of a number. And we know in maths, of is multiplication. All right? That means times the number. And now we know our number is x. So that's 1/3 times x is added. That is plus 1/5 of the same number. 1/5. All right? That is 1/5. That's 1/5 of the same number. Of is times. Times the same number, and the number is still x. Now, when you add 1/3 of this number to 1/5 of the same number, what you had as an answer was 8. So after doing all this, that should be now equal to 8. So now we need to use this to find the value of x, and that will be our number. But again, we know we can simplify this a bit further, because when you multiply 1/3 times x, that should give you x/3. That is simply because x can be written as x/1, which means 1 times x is x, and 3 times 1 is 3. So you get x/3 plus 1/5, or therefore if you multiply 1/5 by x, because x is x/1, that is 1 times x, which gives you x/5 times 1 also gives you 5, and that is equal to 8. Now this is what we need to solve now. But what we are having here are fractions, all right? So we need to get rid of the fractions. How do we do that? We look at the denominators, which are 3 and 5, and then find their lowest common multiple. That's their LCM, all right? That is the smallest number that both 3 and 5 divide with no remainder. And we know the smallest number that can be divided by both 3 and 5 without any remainder would be 15. So therefore, we need to multiply every term in the equation by 15. Okay, so we have 15, that's the LCM, being multiplied by x over 3 plus the same 15 being multiplied by x over 5, and that is equal to 15 times 8. Okay, so you multiply each term of the equation by the LCM. Then now you can further simplify this. We know 3 can go into itself once. 3 into 15 would be 5 times. 5 times x should give us 5x plus 5 into 5 would be once. 5 into 15 would be 3 times. 3 times x should give us 3x. And that is equal to 15 times 8. If you multiply 15 times 8 very carefully, that should give us 120. Yes, 120. Now from here, now just simplify. We know that 5x plus 3x, those two terms are alike. So therefore, they can be added. And if you add 5x plus 3x, that should simply give us 8x equals 120. 8x reads as 8 times x. That is a multiplication, which you undo by dividing. So, over 8 over 8. 8 cancels out from this side. X is left there now. 8 can go into 8 into 12 would only be once. But there will be a remainder of 4. Okay? And then 8 into 40 should give us 5. So therefore, our number was 15. All right? Again, if you put that 15 back to our equation, it should prove right. Okay? Now, before I leave you, I'm going to leave you with at least 2 questions to try at home, so that when we meet again, we will solve it together. So here they go. Only 2 questions, all right? Question number 1 says, when 2 times a number is reduced by 1, the answer is 7. Find the number. When 2 times a number is reduced by 1, the answer is 7. Find the number. That is question number 1. Question number 2. Lamin multiplies a number by 4 and then added 3. The answer is 23. Find Lamin's number. Lamin multiplies a number by 4 and then added 3. The answer is 23. Find Lamin's number. Use that to keep yourself busy and try to stay safe by practicing personal hygiene and then staying away from crowds. Thank you.